All right, we are starting chapter 2 today. We are still going to see some review from Algebra 1, just like in chapter 1. And today we're going to focus on solving linear equations and inequalities. So I asked you to use the distributive property for A. So when you're using the distributive property, you are multiplying by -4 to get -40 minus 12x. You also need to make sure that you distribute this negative. It's a -1. Once you do the distributive property, the next step is to combine your like terms. So I'm going to combine all of my x's together to get -13x. I have -40 and -8, which will be -48. And then we can start to solve by moving all of our numbers to one side, getting the variable by itself on the other side. Okay, and we're doing this without a calculator. We're trying to reactivate some of those mental math skills that we haven't used for a little bit. So when we're subtracting 9, one strategy you can use is you can subtract 10 and then add 1 back. Sometimes that's easier to do in your head. Okay, and then how many times does 13 go into 39? 3 times, so this would be -3. Okay, and then you can always plug -3 back in and make sure that if you plug in -3, it equals -9, because 10 minus 9 would be 1. You'd have -4. Here you'd have -5. -4 minus 5 would be -9. You can always do that mental check as well. All right, now with the second one, we have fractions. So again, we're doing this without our calculator. The first step is to get all the numbers to one side. So we're going to subtract 3/4. But with fractions, you have to make sure that you are working with the same denominator. So if the denominator is 4, to move it to 8, what did you have to multiply 4 by? 2. So if you did that to the bottom, you got to do it to the top. So what you're doing is 5 minus 6, which is just -1, and the denominator stays the same. Okay, now don't forget when you bring this down that you're bringing down the negative that's in front of it. Okay, and some people when they see this, they think, oh, I'm just going to divide by a -1/2. Yep, you can absolutely do that. When you have two fractions, though, it's also helpful to think of it as multiplying by the what? Reciprocal. What's the reciprocal of -1/2? -2, because you flip it, but the sign does stay the same. So -2 times -1/2 is just 1n. And then if you're multiplying these straight across, just think of it like this. Negative times a negative is a positive. What goes into both 2 and 8? What number goes into both 2 and 8? 2. So when you reduce it, divided by 2. Okay, so you're just dividing this by 2, dividing this by 2. All right. Example 2 is going to feel like one of those riddles that you read on your parents' Facebook that they're trying to figure out, right? Okay, there are 6 people in Jacob's family. Jacob's sister is 5 years younger than he is. He has twin brothers who are 3 years older than he is. His mom is 3 times Jacob's age, and his dad is 4 years older than his mom. Is your head going to explode yet? Okay. And then it says the total of all the ages of all of his family members is 165 years. How old is Jacob? So that's what we're trying to find. How old is Jacob? Now, they're also asking you to define a variable. So we're going to do that. We're going to write an equation. So define a variable. That's one thing we're going to do. Write an equation. That's the next thing. And then solve the problem, which is how old is Jacob? Okay, so everything here revolves around Jacob's age. And so our variable, you can choose whatever you want. I decided to choose A because it would stand for the age. You could choose X. Okay, so A is going to be Jacob's age. All right, now let's just talk about this piece by piece. So there are 6 people in his family. His sister is 5 years younger than he is. So if Jacob is A, how could we represent his sister here? A minus 5. Okay, he has twin brothers who are 3 years older than he is. So if 5 years younger is minus 5, 3 years older is going to be A plus 3. Now because there are twins, you can just multiply it by 2, or you could also just do A plus 3 twice. Either one will be acceptable. Okay, his mom is 3 times Jacob's age, so what's that going to be? Yep, 3A. And then his dad is 4 years older than his mom. You guys think about how we do that? Yep, so if his mom is 3A and he's 4 years older, it would be 3A plus 4. And the total of all of them are 165. Do I have everything? So there's 6 people in his family. Do I have all 6 people represented? Who am I missing? Yep, so I have the twins here, his sister here. Yeah, what about just Jacob? Don't forget Jacob. Better put an A plus there. Okay, so we gotta have Jacob. So now we have Jacob, his sister, the twins, his mom, his dad. Okay, so this is our equation. So we define the variable, now we have the equation, now we're going to solve the equation. Okay, and so this is going to be 2A plus 6. And then I just wrote this all out again. And then I'm going to combine my like terms. I'm fine if you start combining your like terms early, that is perfectly fine. Okay, so we're going to combine all the A's. So you guys total that up and write that below. Okay, what do we get? How many A's?
10.
10. Yep, 1, 2, 3, 4, 4 and 6, be 10. Okay, now we're going to do the numbers. So we have -5 and 6, which is 1, 1 and 4, which is 5. Okay, then we're going to solve, so we're going to subtract 5 from both sides. So we have 10A equals 160. And when you're dividing by 10, remember how the zeros just cancel out? So A is equal to 16. Okay, so what that means in our context is what? What does the 16 represent? Yes, he is. Jacob is 16 years old. Okay, for example 3, you are solving for a variable. This is a review from geometry. So the formula A for a trapezoid is given by A equals 1/2 times the height multiplied by the sum of the bases. And you are solving the formula for base 1. Okay, so you may see the same formula again, and you might just be solving for a different variable. That can happen. What we're going to do is when you are solving, you have to use your reverse order of operations. Remember, please excuse my dear Aunt Sally. Yep. So when you're solving, you go in the reverse order. Okay, so if you have multiplication or division, you do that first. Again, if you have a fraction, think of it as multiplying by the reciprocal. That is usually easier to do because then you aren't thinking of A divided by a half, right? You just know that it's 2 times A. Okay, and when you are doing this, you have to show it step by step. The solving is part of your process. And then I still have something multiplied, so I'm going to use division. So 2A over H. And then once you have what's inside the parentheses all alone, you don't even need your parentheses anymore. Okay, and if you're solving for B sub 1, you're going to subtract each side by B sub 2. So 2A over H minus B sub 2, that is your final answer. Okay, your answer will be the equation. Do you guys remember doing anything like that in geometry? Definitely your trapezoid formula. Okay, and then we're still working with some linear equations here. So we are solving linear equations by graphing, and there's going to be some terminology here that we want to make sure we understand. So the solution of an equation is called a root. The solution is called a root. And you can find that by examining the graph. We're also going to be finding related equations today. And the related equation is found by solving the equation for 0. So this is something we're going to use today. Okay, so a related function can be found by solving the equation for 0. All right, and then the values of x for when you solve, when you set it equal to 0, are called zeros. So the values that make that true are called zeros. And that is the same thing as the x-intercept. The 0 of a function is the x-intercept of the graph. Okay, so the solution and root of a linear equation are the same as the 0 and the x-intercept of the related function. Okay, so those terms are interchangeable. This here, that's your x-intercept. Okay, where it crosses the x-axis. Anytime you have an x-intercept, remember, the y value is always 0. That's why you can set it equal to 0 and solve. And all of these terms are interchangeable. So directions might tell you to find the solution. They might tell you to find a root. They might tell you to find the zeros. It might tell you to find the x-intercept. All of those are the same exact thing. Okay, also, the book wrote this wrong, because this should be plus. See how here it's plus? So I think they just made a typo there, so we'll fix it for them. Okay, so I took this directly from your textbook. Has this same information here. The solutions, the root, the zeros, the x-intercepts are all the same. So what we're going to do is we're going to find the related function. Now notice here it says the related function is found by solving the equation for 0. So what we're going to do here when we find the related function is we are going to write that in the form of f of x equals mx plus b after we set that equal to 0. Okay, so we have to find the related function, then we are going to graph the related function. And we're going to use the graph to solve the equation. Okay, so the first thing we're going to do is we are going to make sure that this is set equal to 0. So we're going to move everything to one side of the equation. So that 0 is on this side, and this would be x minus 4. So the related function is f of x equals x minus 4. Okay, we are using f of x because it is a function. Again, you want it to be equal to 0, and then you are replacing 0 with your f of x. Okay, then we're going to graph. So these are using the same skills that we did in our last section, our last chapter, where you have negative 4 is your y-intercept. And then if your slope is 1, you go up 1 over 1. And that continues. Make sure you do this a few times. I did notice on some of our tests that sometimes we got a little bit sloppy and then our graphs got inaccurate. So make sure that you have an accurate line here. Okay, I gave you the straight edges so that you can make a nice picture and an accurate representation. And then your solution is going to be where your x-intercept is. So right here is our x-intercept at positive 4. So it's going to be x equals 4. Now they asked us to use the graph, so that's what we're doing. But also keep in mind, you guys know how to solve this equation, right? If you were solving this for x, what would you do to both sides? Just add 4, and then you'd have x equals 4. So that's a good thing to check to make sure you graphed it correctly. Okay, so based on what we did for A, can you guys do part B? So write the related function, and then you're going to graph. So remember when you're doing the related function, everything gets moved to one side. That's a little different than solving. So because this is by itself here, we're going to move the negative 1. So we do the opposite. We're going to add 1. Okay, so then this gives you negative 1/3 x plus 2. So your related function is f of x equals negative 1/3 x plus 2. Okay, that's your related function. So then on our graph, we're going to start at 2. Now, if it's a negative slope, you're going to go down, but then you're still going to the right. So down 1 over 1, 2, 3. Down 1 over 1, 2, 3. And then let's also go the upper way a couple times. So if you go up 1, that's when you go to the left. 1, 2, 3. Up 1, 1, 2, 3. A nice little dance. 1, 2, 3. And then we're connecting those with our straight edge so that we have an accurate graph that spans your grid. Okay, and then your x-intercept is where? Yes. Okay, so that means your x value is equal to 6. Okay, what questions do you guys have for me about the graphing? Okay, so you will need to do your graphs on graph paper. I have some graph paper for you if you do not have your own. They don't have the nice little graphs on them. You'll have to do your own graphs. Okay, and then example 6. So I was keeping this the same as was in the textbook. So that's why I said skip example 5, like you won't have any in that section. Example 6 is solving inequalities. Now, inequalities are very similar to equations. We just have to watch out for one thing. Do you guys remember? We talked about this last week. What do you have to be careful of? Yes, if you're dividing by a negative, or if you are, what? Multiplying. So if you divide or multiply by a negative, the sign switches. Okay, so don't forget to switch that sign if you divide by a negative. So again, we're doing this without a calculator. You have 1.4 and negative 2.9. When the negative is bigger, it is easier to just subtract them. So I like to line mine up. So if I do 2.9 minus 1.4, right? 9 minus 4 is 5. 2 minus 1 is 1. So I have negative 1.5c. And then I'm going to get all of my c's on one side. So if you have two negatives, you really can just add them. 3.5 plus 1.5. What's that going to be? So can you add the half up? So negative 1.5 and a half is what? It would be negative 5c. Yeah, so if you add the half, negative 2, negative 3, negative 5. I know we're dusting off some of our mental math skills, but it's really, really going to help strengthen you as a math student. And then, dun, 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 I'm dividing by a negative, which means I have to, oh no, oh no, oh no. So that means I have to flip my sign. I'm just going to put a little flip as my reminder. Okay, now if you're doing this in your head, instead of thinking of the decimal, let's just do 75 divided by 5. What's 75 divided by 5? And if you aren't sure, you can just say, oh, it goes in there once, right? How many times does 5 go into 25? 15. So what you did is you moved the decimal over 1. You just got to move it back. So c is less than 1.5. Okay, so then we're going to graph the solution set on a number line. We're also going to write out our solution set in set builder notation, which is c, such that c is less than 1.5. Okay, and with your number lines, I'm not super picky about what your scales are. I really just want you to make sure you have 3 things labeled on there. So, oh, sorry, and that's negative, so you got to keep this negative. Positive divided by negative is a negative. Okay, and then when I say I don't care what your scale is, I mean you could just make this negative 1. You can make this negative 2. As long as you have something before and after it labeled, that's fine. And then we have to pay attention to our sign. So if this is just a less than, we are going to have an open circle because there's no equal to. Okay, so if they're less than negative 1.5, does that go to the left or the right? Which way does our arrow go? Left. And I always remember less than goes to the left if you have your variable first. Also, can you see how the arrows are going in the same direction? As long as you have your variable on the left side, that will always be true. The arrow should match the direction. All right, so for B, let's start by using the distributive property. So 3 times 2y is 6y, 3 times negative 1 is negative 3. And then from here, there are so many different ways that you could do this. What I'm going to do is I'm going to get all of my numbers on one side first because I want to undo this fraction. Because if I can avoid working with a fraction, I will. So what that does is it gives me 6y minus 5, and then I have y over negative 4, and that allows me to do what? Yes, multiply everything by negative 4. Okay, so then those will divide to make 1. I'll have negative, uh-oh. Did I do this right? What did we just do? Yep. Okay, so if you multiply by a negative, then we are going to flip it. Okay, so anytime you're multiplying or dividing by a negative, you are going to flip it. Okay, now I can get all my y's together. So I'm going to add 24y. And then can you guys reduce your fraction if you haven't already? Okay, so what goes in about 20, 25? 5. Okay, so this is just one way to solve it. You guys could have got all the y's together first. Remember, this is like a negative 1/4 y. I just thought that was the easiest way to do it, but remember that anytime you have a variable over a number, it really just is a fraction. Okay, so if you got all of your y's together, do you guys remember how to make a mixed number into an improper fraction? Multiply, then add, yeah. So you have 25 over 4y. And you could solve it, right? Add 3, multiply by the reciprocal, you'd end up in the same situation. Okay, so I just showed you one way to do that. All right, so then let's write this in our set notation. What type of circle are we going to have on our graph? Yep. Is there a certain scale you guys want to go by? Because we just have to label on either side. Yeah, I would go by fifths, because then this would be 1, this would be 3/5. Okay, and then you have a closed circle. Make sure you fill it in. Everything will go to the right because it's greater than or equal to. All right, I'm going to give you a moment to read over that story problem because there's a lot going on there. And then if you want to try to write out your inequality, you are welcome to do that. I'm just going to be quiet for a minute so you guys can read it. All right, then I see some people circling some key values or underlining some key values or highlighting something. Excellent. A great way to tackle a story problem like this is to either highlight, circle, underline, or to pull those out so that you aren't getting lost in the words. Okay, so the recommended daily intake for teens of calcium is the 1,300 milligrams, and Jake gets 237 milligrams of calcium from a multivitamin he takes, 302 milligrams from each glass of skim milk that he drinks. What we need to find is how many glasses of milk would he need to drink to meet the recommendation. And then it says we have to interpret the solution in context of the situation. So we have to make sure we have a sentence that ties all of that together. Okay, so just like we did earlier today, we are going to define a variable. This is all based on the glasses of milk, right? It's asking how many he would need to drink. So we can let the G equal the glasses of milk. Again, if you want to use X, that is perfectly fine. That's why you're defining your variable. Okay, and then we're writing an inequality to represent the situation. Okay, so we have the 237 milligrams, the 1,300 milligrams, the 302 milligrams. Let's start sorting through what each of these means. So he gets the 237 from a multivitamin. How many of those is he having? This one. Okay, so he's going to have the 237 milligrams and 302 from each glass of skim milk. That's what we're trying to find. So how am I going to write that in my inequality? Yep, I'm going to use G just because that's what I defined. So because it's per glass, okay, I'm going to put that there. Okay, and then we know that he needs to meet the recommendation, okay? We are doing an inequality. So if he meets the recommendation, can he exceed it or should it be under it? He can exceed it. It has to be at least that amount. So is this going to be greater than equal to or less than equal to? So he can get more than 1,300, right? That means 1,300 is the least amount he can get. So the arrow should be pointing at the 1,300 because this quantity could be more. Okay, he just at the very least has to get the 1,300. Okay, so we did the vitamin plus the milk glasses. Okay, it's at least the, I'm going to put daily the daily recommended value. Okay, and then from there, we just have to solve that for G, and I'm going to let you use a calculator for your story problems. We're going to subtract 237 from both sides. And you should get 1,063. And then we're going to divide each side by 302. And then I want you to start thinking about approximately what you should have. How many times do we know that 300 goes into 1,000 at least? Yeah, at least 3 times. So when you divide and you get a decimal, we're going to round to the nearest 100. Because they don't tell you what to round to, we'll round to that. Okay, and then when you divide, you'll get about 3.52. Okay, so that is solving the inequality. That's our step 2. And the last thing we're going to do is interpret that. Okay, so what does this mean? G is greater than or equal to 3.52. What does that mean in terms of the situation? Yep, and so because it's a little bit more, I'm just going to say slightly more. So, yep, Jake needs to drink slightly more than 3.5 glasses of milk to get the daily recommended amount of calcium. Okay, so that's exactly what our situation is. You have to drink slightly more than 3.5 glasses of milk to get the daily recommended amount of calcium. Okay, so we need all of that for the context of the situation. All right, and then after I write down your homework, I will put up the book for you. I also put graph paper in that purple bin back there, so if you need a piece, you may use that. Okay, and then I also